Okay, so the question today for coding is called factory machines. So basically, the idea is that we have in machines that can be used to make products. Your idea is to make tea products. And for each machine, you know the number of seconds it takes to make a single product. It can work simultaneously, and you can decide what is the shortest time to make the tea products. So basically, the idea is just kind of concurrent programming and just how to make it the fastest, efficient as possible, right? So if we were to take the brute force approach of actually simulating this, like factory this, producing that, like that's not realistic. We're going to run out of time for that. So the different approach we're going to take is just using binary search. Just going to assume, okay, if our um, time was answer was this, then let's assume, okay, so that's the time, right? And then we're gonna work backwards to be like, okay, how many can we make? If we can make more than that, then that means that that is not our hard limit and we can go shorter. And if we can't make that much, then we know that we need to actually increase the time, right? So that's just kind of the approach. It's just to use this binary search to cut down the interval by half every time. Okay, so let's look at the code. So the starting points are pretty similar, include bits std c++.h, pretty standard, using namespace std. We're going to use long long just to make sure that we're not exceeding the limit. And then we make our input faster by LOS-based Sync with Studio and scene.ty. And then we have our n, our t, we input those, we create our own vector. And then what we do is a for loop to get our inputs. Then we're just going to establish a low boundary and a high boundary that are relatively large, and we make sure that's always inside. And we're going to set our answer to be the high value, just to update that. And then we're going to do while low is smaller than or equal to high, we're starting our binary search. And what we do here is we just set our mid to be equal to the value of low plus high divided by 2. Here it's just to make sure that we're not exceeding the boundary. It's just a nicer way to do that. And then products equals 0. And then we just look at it and see how many products we can produce during that time. If we can do it, it's bigger than t, then we just break and we know that, okay, at this point we already produced enough, so the answer must be equal to this or smaller. So we're going to just update our boundary. And then otherwise, if we didn't make enough, then we're too low. So then we're going to update our low boundary to that point. And then important thing to note here is low and high are just the boundary because we tested the boundary, you can move it one more further down to closer to the boundary. And then our answer is mid because we just tested that value and we're not sure. So we're going to store that as the value. And in the end, we return our answer after low is smaller than or equal to high. So yeah, that kind of brings us to the end. I think this problem was pretty straightforward. The main thing was just kind of thinking, okay, if you know this and it happens at the same time, normal simulation won't work. The minute you kind of break out of the normal simulation, then the binary search kind of makes sense and it is pretty straightforward.